Precalculus now. So we're gonna talk about that. So today you're gonna need graphing paper, lots and lots of graphing paper.
I shit graphing paper, Mr. J.
No, I don't. What do I look like? Walmart?
What do I look like? Office Depot? Huh? Bro, most of these are pretty. Do I look like a? Do you look like yeah. Do I look like that different most of the shit scrapping? We don't have this. But wait, actually, I might have like one or two. What? It's all like homework books. That's not how I was.
So we're gonna talk about some of those graph, and most of the graph you know, but we're gonna talk about the detail of those graph. So we're gonna talk about domain and range. We're gonna talk about the coordinates. We're gonna talk about everything that in detail about those. So it's a lot more extensive than what you had before. So, oh, you guys have paper? Are we not ready? Let's go. Today's gonna be a boring lesson. I'm sorry. You're gonna zone out for a little bit. Don't zone out. Usually I told people that you can form a t-chart. And t-charts is significant because a lot of you guys says, well, that's like so pre-algebra. It is, but it's important for you guys to know how this number come in play. So if I plug in -2 into the x, I'm gonna get -2 for the y. That's the input, output, dependable variable, independable variable. So plug in -1, that's gonna get -1, 0, 0, 1, 1, and 2, 2. So this is very important that you have this value here, you plug in. And you know it doesn't matter what value you plug in, it's gonna have the same thing. Now, you did do this on the test, right?
What? Yes.
Graph this line. Just simple as graphing this line. This is where that's inverse is symmetry of. Okay, so that is pretty easy. Well, y equal to x looks like a straight line. Straight line, right? Straight line. Line. At 45-degree angle. 45-degree angle from the x-axis, right? So 45 degrees. Now you don't have to know that, I just kind of give you like the extra information. So now what we're going to do is we're going to talk about this. We're going to talk about in terms of what is the domain of this function. Domain is going to be what? Our real number. When you don't know anything, put down our real number. Half the time you're going to get it right. The other half is going to get it wrong. That's okay. It's like true and false questions, right? Negative infinity to infinity, and the range is going to be negative infinity to infinity. And we're going to talk about how do I get negative infinity to infinity. The reason being is xi can be any value and y can be any value as well. Or also another thing is looking at the graphing perspective. This line is going to be keep on extending, right? And this line is extending both ways. So if I were to take a marker, if I'm going from left to right to check the domain, I'm going to intersect with this the shadow of this marker. Okay? Because this line is going to extend all the way here, so it's going to intersect here, it's going to intersect here. At all moments, it's going to intersect if I do it horizontally. Range is going to go from low to up. So we're going to talk about this. So it's intersecting because our lines keep on extending. So it's going to intersecting. So domain and range is going to be possible to have those. Okay. Now we're going to talk about something we never talked about, which is what kind of function this is? Even function or odd function? How many guys hear even odd function before? You do? What does that mean? Do you remember? Or no?
You know, like if it's pointing up or down.
No? Josephine? Not really. Okay, so this even a line we can talk about higher complexity, right? So we can say that this is a odd functions.
Do you want to eat it?
Okay, odd function. The reason why it's called R function is gonna be symmetry to origin. And we're gonna keep on talking about this to all the functions. So symmetry to origin. Why symmetry to origin? If you think about it, they are symmetry to each other. You think about it. Symmetry to this dot, not symmetry to y equal to x. There's a difference. Symmetry to this dot. Okay, so this dot origin, this is the origin, so it's symmetry to that. And also you can tell this is -1, and this is a 1. So if it's a 1, it's gonna be 1. If it's -1, it's gonna be -1, but it's 2, and here it's gonna be exactly opposite. So the output is almost exact opposite. So the output is kind of opposite to each other. Output is opposite. That is why it is R functions. Or symmetry to origin on the graph. So origin is a big deal, symmetry to origin. 99% of functions are not odd nor even. But in this case, they are odd functions. So even a straight line, we can talk about a lot of stuff. So then we can go into this. Question about a line. Can I erase it or no? Yes. So those are the simple things that we can talk about a line, and you can probably think about, you kind of take everything for granted. You say, okay, yeah, I already know this, but there's a lot of things that you still don't know. Can I move on?
Yeah.
Okay. We're going to talk about the next one. Y equal to x squared. We already talked about this when we talked about inverse, but now we're going to talk about more extensive of it. So -2, if I plug in -2 into the x, so that's going to be -2 squared, that's equal to 4, right? If I plug in -1, what am I going to get? 1. If I plug in 0, plug in 1, 4, right? Now I'm going to plug in all the coordinates. So 0, 1, 1, so this is very standard, this one. And even if I plug in 3, it's going to be 9, I think.
Yeah.
So 9 is right here. So there was a so y equal to x squared looks like U shape. Looks like U shape. And not only looks like U shape, it has a vertex. Vertex is 0, 0, so which is this point. 0, 0. It's called vertex. It has an axis symmetry. Which is right here. So x equal to 0. It has domain and range as well. What is domain in this case? Let me see. Carlos, what's domain in this case?
Positive, negative infinity.
Good job. And what will be a range, Nicholas?
Where would it be?
No, but the graph's still extensive and you're looking at x direction. So what do you do is, yes, Benjamin?
So, may I say the range?
Yeah.
Yeah, so the range is 0 to 3.
Oh, okay, so this is how can you tell. You take a marker and look at the shadow of the marker, right? When they start, always go from down to up, and so red domain is gonna test this region. So this region is gonna test, but this line is gonna be extensive, right?
Yeah.
Extended. So they are intersecting at any points. And especially they're gonna intersect in the middle part, but this line still continuous going. Remember this marker is like infinite long, so it's gonna touch those graph anyway, so the domain is gonna be all real number. Your range is gonna be, however, it's gonna test on the bottom, and you're gonna look at the graph. You're gonna see, oh, when it first intersect is at 0. So it should including 0. And that's why you have a bracket, and it's gonna go up. So intersect keep on left, it's gonna be infinity. So it'll be 0 to infinity. Is this an even or odd functions? Even. Like your face, a even. Your face, not odd. What's up, Benjamin? Odd face. Odd? No, sorry, even. Functions. Because of the symmetries. If you look at a graph, it's symmetries. Symmetry to y-axis. Symmetry to y-axis. Now the vertex, I'm gonna have a different name. In my class, I'm gonna call it vertex majority of the time. A lot of time, like 10% of the time, I'm gonna call something else that does not apply to all math class, only in this class. We're gonna call it anchor, anchor point. So because why they call it anchor is because when the transformation is really due to the part. So think about your chin. If I can see your chin is, then I can see where your head is, pretty much. Because your chin kind of decide where to move. Okay? Those of you guys play basketball. Anybody play basketball in this room? You do? Okay, when you play defense, you're supposed to look at a person's head. You're not supposed to look at the body. You're supposed to look at a person's head because the head's not gonna lie. Okay? A lot of people are looking at the head, but you look at the head's not, the head is where that's what's gonna move. Okay? So that's pretty much what it is. So, question about this part? No? Okay. We're gonna talk about the next part. Can you erase it? Yes.
What happened if it's like?
Oh, we haven't get to there. We'll get there. Okay, so question about this part? Questions? Okay. We're gonna talk about next one. It's gonna be we check this. Say yes. 1 down, 1, 2 down, 4 to go. Y equal to absolute value x. Absolute value x, and you're gonna plug in the t-chart just like what you used to. X, y. And if I plug in -2, what am I gonna get? If I plug in -1, 0, 1, 2, right? And you say, okay, what does that graph look like? Well, it looks like this. Yes. The last one we did say look like a U, right? Did I say look like a U?
Yeah.
I did?
Yeah.
I don't remember. So, Alzheimer's. So, y equal to absolute value x. It looks like, so we're gonna give you a nickname. It looks like a V. The V shape. V shape. Right? And it has a vertex of 0, 0. Or we're gonna call it anchor point sometimes. Okay, so it's anchored. It has a domain. Okay, so now I'm gonna call on people. What will be the domain in this case? Fanny? What will be the domain in this case? Perfect. If you don't know, when you doubt, it's always a real number. Okay, range. I'm gonna say, Maria, what would be a range here? Good. 0 to where? Perfect, because that's when it starts intersecting. Good job. Is it including 0 or not including 0? Is it including 0 or not including 0?
0.
Is it including 0 or not including? Is bracket?
Yeah.
Then that's good. Okay, so there's anchor point. Is this even or odd functions?
Even.
Why?
Because it's flipping across the y-axis.
Yes. So there's the even functions because the symmetry to y-axis. Okay, so I'm gonna take the shadow, the marker again. I'm gonna go from below. Range is going from the y. Looking at the y. When does the y start intersecting? Right. It's not intersecting any line, right? Because that line never go to the bottom, right? So when it intersecting is right here, and then go up. So it'll be 0 to infinity. There's the axis symmetry as well. Okay, because the even function, there's always symmetry is to the y. What else do I need to know? Oh, talk about something very important. A lot of you guys don't know this. In algebra 2, it should talk about this. Definition of absolute value. Definition of absolute value. So definition of absolute value is this. Is f of x equal to absolute value of x. You can rewrite this into f of x in terms of piecewise functions. Okay, in terms of piecewise function. So I'm going to break this function into 2 pieces. And why is 2 pieces important? Because you have to understand this is not only one function here. There's a 2 function, y equal to x. When x greater than 0, negative x when x is less than 0. So those are the definition of absolute value. So true definition, you should have to break to pieces. And that's very important when you're going to come to calculus. Very, very, very important. Okay, so we're going to talk about that a little bit more next year, but this is a kind of introduction. So next time when I just say definition of absolute value, you're going to say that is definition of value because that's a piecewise functions. Got it? Can I move on? Gabriel, you got it?
Yeah.
Okay, definition of absolute value. Very big deal for those of you guys that are going to calc. Go to the next one. Check. Y equal to x cubed. T chart. Should be easy. What's the negative 2 gonna get? If I plug in negative 2 into x cubed,
Negative. So I corrected myself.
is equal to negative 8. And that's equal to what? 1, negative 1? 0, 1, and 8. So if I plug in, I'm gonna get negative 2 is gonna be 8. This one's 1. It looks like this. So y equal to x to the cube looks like a waterfall.
A what?
A waterfall. Kind of like, you know, kind of like a waterfall. Okay, so you say, okay, is any vertex? There's no vertex. Vertex is the lowest value or the highest value, but so that's why in this case I'm going to call the anchor point. 0, 0 is anchor point. So you start at this point right here. It's anchor. This is how the graph translate. If that is translated to here, translate up or down. Is domain and range. All real number, good, because this line is gonna keep on getting wider. It just very slowly, very, very, very slowly. But it's still gonna get wider, so it's gonna be the graph, if we keep on zooming out, you're gonna see that line still getting wider. And the range is gonna be all real number as well.
I love this one.
What?
I said it was so cool.
Okay, so, what a nerd. Why equal to execute? Looks like a waterfall, 0, 0, anchor point, domain, range. Now, what would be the function? Is that even or odd?
I think it's,
Because why?
it's
Symmetry across
to
X.
origin.
Symmetry to origin. Not only that, you look at this 1 and -1, right? They are exactly same spacing, so 0, 1, -1. If it's 2, it's gonna get 8, that's -8. It's opposite value, so it's opposite value that is gonna be odd functions. And this is gonna be symmetry to origin. And that's pretty much it. I mean, that's not much to add. There's an anchor point, is that to understand 0, 0, that's important. And that's a very, very, the things that you have to pay attention to. Yes?
Wasn't there something like the x1 is a number of turning points or something?
In this case, there's only one turning, right?
Yeah.
That's a maximum. Maximum 3.
Zero.
A maximum, oh, it's 3 minus 1.
Isn't it
So it's 2.
intersections, not turning points?
Huh?
Isn't it intersections, not turning points? So
No, in this case, it just, the turning point is the degree minus 1. So like x squared, right? So it's 2. 2 minus 1 is 1, so it's 1. But in this case, there's actually a 2 turning point, but it's kind of hard to tell, I think. Yes?
So like the x1, it doesn't show the amount of intersections, that.
No, it does not. So it's supposed to have, the 3 is supposed to have 3 solutions, right? But solution can be a complex solutions, or it could be multiplicity. We can talk about multiplicity. So in this case, it's actually x equal to 0 has multiplicity of 3. It's just 0 happened 3 times. Okay. Good question though, yes.
How do you know when the function is odd?
Oh, odd or even? So the odd, you look at the odd, first you can tell the coordinate. You see that 2 and -2, just compare the output. One's 8, one's -8. It's opposite from each other. 1 and -1. If they're opposite from each other, it's symmetry to origin. Also, symmetry to origin is symmetry to this dot. It's not symmetry. So don't get confused, symmetry to origin and symmetry y equal to x. They're completely different things. Okay? This is this. See that? Symmetry to the origin. Next question.
Somebody has Benjamin, what's your favorite thing to do? Benjamin says, look at y equals execute graph.
Just stare at it. You become smarter. Okay, y equal to square root of x. Oh, this one's interesting. xy. Can I plug in any negative value in there?
No.
Or you can, but it's gonna get I, but I is not able to translate on the real graph. It does have an imaginary plane, yes, but we're not able to graph that. That's totally different idea. Okay, so I cannot plug in -1, that's gonna be undefined, or -2 is gonna be undefined. So I'm gonna plug in 0. What happens if I do square root of 0?
0, 0,
Or the square root of 1?
1.
Or the square root of 2? Ah, got you there. Square root of 2 is roughly 1.414. So those numbers good to know because that's good approximation. Square root of 3 is roughly 1.7, and that's approximation. But rest of them you don't need. Rest of them you don't need to know square root of 5, but you do need to know square root of 4. So that's 2. So 0, 0, 1, 1, and I'm just gonna use the obvious value. So I'm not using those 2. But it's good to know square root of 2 and square root of 3. And the OSAT, they used to ask that a lot. They would be like, oh yeah, which one is probably the best approximation of 3 square root of 2? So you take it just 1.4 times 3, and then that was the answer. But most of the people that's without calculus action. So it looks like this. Oh, that's horrible. So it looks like that's better. Okay. It looks like if you can think about it, sideways, half the sideways problem, but for me, I actually have a name. So y equal to square root x. It looks like a quarter of football. Do you see it?
No. Looks like a white.
Quarter of
Oh.
Quarter of football. Okay, so think about this. It's the whole football, right? So that's a quarter. Got it? And you think it's funny because in geometry, you cannot find the volume of a football. Think about what geometric formula to help you find the volume of a football. It's not possible because there is no geometric formula for a football. But there is a way to do it in calculus, so we had to use this way. Kind of look at this type of general shape, and then you can rotate across x-axis. So this line can come outside and go inside the board, and it's going to be a half a football. And then you can find the volume of that. You can find the volume of donuts. Think about how to find the volume of donuts. That's actually very interesting. So it looks like quarter football. What else? Well,
Anchor is 0,
what's the anchor point?
I said 0.
Good. 0, 0. It's right here. So anchor. Not always anchor points at 0, 0 though. You gotta pay attention. Anchor point is not 0, 0 here, and then you say, okay, well, what is this domain in range? This one's kind of interesting. It's no longer all real number. I'm gonna ask Ria, what is the domain in this case? I can hear you. It's not all real number, good. Good. 0 to where? No. From 0 to this line still graphing. Continuous. Yeah. Bracket is including 0. Okay. Kyle, what's the range?
0 infinity.
Perfect. 0 to infinity. When ours fail, infinity to infinity, second try is going to be like 0 to infinity. I'm just kidding. I'll just read the graph, right? Okay, so is this even or odd functions? It's actually neither. Odd nor even. Let's spell right. It's or nor.
Yes, no.
Nor.
We were talking about like it's not something.
Oh, it's nor.
Yeah.
So neither odd nor even. So it's neither functions. 99% of the time it's going to be a neither functions. Neither odd or even. It's really one of the occasions they're going to get even and odd. But when it's even and odd, the problem is a lot easier because there's a lot of symmetry you can talk about. Question about this part. Can I go on to the next one? My most exciting parent function. Okay. Do we talk about missing anything? No. Anchor point 0, 0. Okay, good. 1 over x graph. My favorite one. My favorite one. So of all the parent function, I like this one the most. It has so much thing in this information. 1 over x. And you cannot do t-chart on that because you can do, but you have to plug in more than one value. So we're going to start with a -3. So what happens if I plug in -3?
1/3.
Let's do let's do -4. So it'll be 1 over -4, right?
Yeah.
So that's like a very small value, right? So I have -4 is gonna be right here. Are we okay here?
Mm-hmm.
I'm gonna do -2. It's gonna be what?
Negative 1 over negative
1 over -2 is a halfway.
2.
Does that make sense?
Mm-hmm.
How about the -1? How about, we're gonna plug in more points, so it's gonna be -1/2. So be 1 over -1 over 2.
Which is 2 negative.
Keep change flip, it's -2. Because 1 over that. -1 over 4. Oh, shit. I'm gonna keep on going. So that's gonna be what?
Negative 4.
Is equal to -4, and I'm gonna plug in 1 over 4 is what? 4. If I plug in what? 1 over 2 is what?
2.
2. And then 1 over 1 is 1. And then 2 is what? 1/2. So that's gonna be here, and that's gonna be here, it's gonna be here, it's gonna be here. So,
What the frick?
okay, so this is a very important graph. There's the 2 asymptotes here. Now, this is one of my favorite ones because all my math students for the last 10 years knows this. I create this gang sign for my class. A gang sign, the gang sign looks like this. So if you go to other people says, yeah, which math class are you from? And you just say like this, they know they are from here.
Like this?
Like yeah, 2 L signs upside down to the other one. So look like this graph. See that?
That's fine.
Oh.
Yeah. If you other people, if the other people is asking you which math class, you just say like this, they know.
What?
All my formal students know.
No, right
It looks
hand-
like this.
The right hand is pointing up and the right hand is in front.
Okay, so let me write down
Wait, how?
Looks like gang sign.
This.
The
It
right
looks
hand-
like-
The right hand is pointing up and it's in front.
gang
And the
sign
left is pointing down.
Oh, okay.
from here.
It looks like you put gang sign.
Okay, so domain is gonna be -infinity to 0, union 0 to infinity. Your range is gonna -infinity to 0
I learned about the.
and 0 to infinity. And there's an asymptote, so it's a vertical.
Better hurry.
You're right hand is right, you're
We're gonna be late.
Asymptote is gonna be x equal to 0. Horizontal asymptote.
The first one I think I got like, there was like a rhythm that was wrong.
Y equal to 0. The anchor point is gonna be 0, 0. It's where the asymptote is formed. So if I would graph it, it looks like this. So there's no actual point, but that's where the graph is translating. It's translating based on the asymptote. Okay, so that's pretty much all the information.
I forgot something.
Now.
My bad.
I use.
On.
I remember that.
See? Everybody knows.
I got a question. So that would be like a type of inverse.
Oh, shit.
Yeah, it's actually
I'm just gonna put it here.
reciprocal
You'll
function.
eventually realize it.
It's not called inverse function, it's a reciprocal function. It's reciprocal.
You're a sucker.
It's called reciprocal.